Introduce us.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurusnaimani binti Muhammad Nazimi.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurdina Sofia binti Mak Saleh from DKN 3A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syafiqatullah binti Haznan and I'm from DKN 3A.
First, we go to the introduction. Cylindrical containers are a versatile and popular packaging solution used in a wide range of industries for various purposes. These containers are characterized by their cylindrical shape, which allows for efficient storage and transportation of different types of products, whether are in the food, pharmaceutical, cosmetic, or industrial sector. Cylindrical containers are used in a variety of applications, such as storing liquids, gases, and solids. The surface area of cylindrical container is an important parameter to consider, as it affects the amount of material needed to manufacture the container, as well as its thermal properties. In this report, we will determine the values of radius and height of a cylindrical containers that will minimize the surface area while maintaining a volume between 5 meter cube and 10 meter cube.
First thing first is the acknowledgement. I would like to express my sincere gratitude to those who have supported and guided me throughout the completion of this math assignment. First and foremost, I would like to thank my mathematics lecturer, Madam Nazirah binti Ibrahim, for their valuable insight, passion, explanation, and unwavering dedication to helping me and others to understand the subject matter. Their passion for mathematics has inspired me to delve deeper into the world of numbers and equation. I am also thankful to my group mates who collaborated with me on this assignment. Our discussions and group study session were instrumental in unraveling the complexities of the topics covered. Furthermore, I would like to acknowledge the support of my family for their encouragement and understanding during the time I spent working on this assignment. And their belief in me has been a constant source of motivation. Finally, I appreciate the resources available at KKTM at the KKTM Kuantan Library and online platform, which aided me in gathering relevant information for this assignment. Thank you all for your support and encouragement. This assignment would not have been possible without your help. Thank you.
Okay, next is the objective. First, determine the value of radius and height of a cylindrical container that will minimize its surface area while maintaining a volume between 5 meter cube and 10 meter cube. Second, apply the derivative to solve optimization problems such as finding maximum or minimum value of function. Third, analyze the connection between the first and the minimum of a function and use it to identifying inflection point and concavity and concavity. 4. Analyze and interpret the graphical representation of function and derivatives to gain insight into the behavior of function.
Next, we go to the next part of our assignment, which is calculation. Let's set the volume of the cylindrical container as 7 meter cube. The formula for the volume of cylindrical container in terms of radius r and height h is V equals to pi r power of 2 height, which r is radius and h is height. The formula for the surface area of a closed cylindrical container is A equals to 2 pi power of 2 plus with 2 pi rh. To rewrite the formula in terms of R only, we substitute the expression for H obtained from the volume formula, which is H equal to 7 per pi R power of 2, into the surface area formula, A equals to 2 pi times with 7 per pi R power of 2 plus with 2 pi R power of 2. Simplifying, we got A equals to 14 R power of negative 1 plus 2 pi R power of 2. To minimize the surface area, we need to find the critical points of A with respect to R. We do this by taking the derivative of A with respect to R and setting it to equal to 0, which is dy per dx equal to negative 14 R power of negative 2 plus with 4 pi R power of 2 equals to 0. Solving for R, we got R power of 3 equals to 14 per 4 pi. Substituting the given volume of 7 meter cube, we got R equals to square root 14 divided with 4 pi equals to 1.04. Substituting this value of R into the expression for H obtained from the volume formula, H equal to 7 per pi R power of 2 equals to 7 per pi times with 1.04 power of 2, we get 2.09 meter. Therefore, the values of R and H that minimize the surface area of the cylindrical container with a volume of 7 meter cube are approximately 1.04 meter and 2.06 meter respectively. To confirm that this is a minimum, we need to perform the second derivative test. We take the derivative of dA per dr, which is dy per dx equals to negative 14 r power of negative 2 plus with 4 pi r power of 2. Substituting the values of v and r obtained earlier, we get d power of 2a per dr equals to negative 14 r power of 2 plus with 4 pi r. Substituting the values of v and r obtained earlier, we get d power of 2a per dr equals to negative 2 times with negative 14 r power of negative 3 plus with 4 pi, we get 37.96. Since d power of 2a per dr power of 2 is positive, this confirms that the critical point we found is a minimum. Therefore, we can conclude that a cylindrical container with a volume of 7 meter cube and a radius of approximately 1.04 meter and height of approximately 2.06 meter has the minimum surface area.
This is our example using CATIA V5.
And lastly, for the conclusion, in this project, we determine the optimal value of radius and height of a cylindrical container that minimize its surface area while maintaining a volume between 5 meter cube and 10 meter cube. The optimal radius and height are approximately 1.4 meter and diameter of 2.08 and minimum area is 37.96 respectively. And this information can be useful in designing and manufacturing cylindrical container with optimal surface area.
So this is our reference. Thank you for listening our presentation. Bye bye.